To figure out what mechanism operates, you need to analyze the alkyl halide. And for the SN1 reaction, we have carbocations that are involved. So we know that it's going to be a tertiary substrate that leads to a tertiary carbocation that's most stable. Now for the SN2 reaction, we know that it's dominated by sterics, and a primary alkyl halide is easiest and most reactive in these reactions. Now when you have a secondary alkyl halide, the reaction can operate through either of the two mechanisms, and other factors are going to determine which mechanism operates, such as the strength of the nucleophile or the nature of the solvent or something like that. So let's go ahead and analyze these alkyl halides given to us. You want to, of course, identify the halogen or the leaving group, identify the alpha carbon, and then count carbons attached to that carbon. There are two here, so we would classify this as a secondary alkyl halide. And so for A, either mechanism can occur. For molecule B, we again want to identify the halogen, identify what's called the alpha carbon, and then count how many carbons are attached to that. There's just one here. So we would call this a primary alkyl halide, and primary alkyl halides react exclusively through SN2 reaction mechanisms. Molecule C, here's our halogen, here's our alpha carbon, and you want to very carefully identify the number of carbons attached to that. Here again we have a secondary alkyl halide, and secondary alkyl halides can react by SN1 or SN2 to give you the substitution products. In molecule D, we have the halogen. This carbon right here is the alpha carbon, and then we count the carbons that are attached to that alpha carbon. There are three, so we call this a tertiary alkyl halide. Tertiary alkyl halides react exclusively by SN1 because the tertiary carbocation is very stable, and it can't be SN2 because it's just too sterically hindered for the nucleophile to kick off the leaving group. So thanks for watching, and I hope you enjoy this video.